Greetings to one and all. On behalf of family members of CSIR-Fourth, it gives me great pleasure to extend a warm welcome to each and every one of you gathered here today. I request our head ma'am to please accompany Shri Somanath ji sir onto the dais, please. Thank you, ma'am. It's my honor and privilege to extend a special invitation to our esteemed society member, Shri Somanath ji, our secretary to DOS, chairman ISRO, who happens to be mentor to our institute. And sir, it's really indeed our honor and proud to have you as our mentor. I request our head Dr. Shri Devi ma'am to please welcome Somanath sir with a flower bouquet. Now I request our head ma'am to please welcome the gathering and also to give her remarks. Please ma'am.
Please check whether they loaded. Good afternoon to one and all my colleagues here, and I warmly welcome Shri Somanath ji, Chairman ISRO, Secretary Department of Space. It's my honor that he accepted our invitation. We went and met him, I think last year sometime in June. But then, that time he said he'll come, but then I think he got busy with that launch and all that. So we couldn't have him. Then finally today, it was meant to be today. So we are having him today here. I know all of you, I will not come much in between you and the address of ISRO chairman. But I thought I will give a little glimpse of our activities before So I made a 10-slide PPT so that you see, we actually have a video, but I thought that doesn't look nice. So I made a PPT. I thought I'll only explain about Fourth Paradigm Institute. So you may be aware that Fourth Paradigm is basically big data science. First being the observation, first paradigm, second being analytical equations, third being computational power, fourth is the big data science. Now we are entering the fifth paradigm. Maybe CSIR, we will only emerge as a fifth paradigm institute also in future, maybe 10 years down the line. So here actually what we were a very young institute compared to CSIR, which has a rich history, like 1942, it was pre-independence, it was formed. But we are actually a very new lab, maybe 11 years old, 2013. Before that we were a center under the administrative control of NAL. So then we were made into a lab in 2013. Then we had some teething issues in terms of autonomy and all. When you are separating out from a big brother, then you will have teething issues. So we had some, but now it's kind of sorted out. Now we are a full-fledged institute with all infrastructure, admin, everything. We are working towards enabling CSIR in the data science arena. So yeah, you put it in the slideshow mode. Yeah, the next slide. So this is our organizational structure. So we are under Director General CSIR. We have a Research and Management Council, which is called Advisory Council, and then we have two scientific divisions. One is Big Data Research and Supercomputing Division, other is Interdisciplinary Data Research Division, and we also have academic wing of CSIR Academy where they give masters and PhD degrees. So we only give PhD, we don't give masters here. Then we have meta scientific divisions, Technical Management Division for project monitoring, business development. Then we have this PAN CSIR skill and Jigyasa activity. Skill is for college students and Jigyasa is for high school students from 8th to 12th. So we give them glimpse of what we are doing, and we also conduct some workshop and training for them. So that also comes under this. And other than that, we have our own admin, stores, purchase, finance, everything, all independent now. Next slide. So yeah, this is the thrust areas of 4pi. One is that our major is that we have to enable interdisciplinary data driven translational research. So right now we do research that you would be seeing cyber security and data privacy research. So we have a cyber security test bed, we have a presentation also, so I won't go into details of that. Then when we were coming, we were telling you the CHAMP facility, that is a supercomputing, total 3 petaflops plus 1.2 petaflops of AMD machine, totally 4.2 petaflops we have. And we are also setting up CSIR cloud storage mega. So this year we have, last financial year we had set up the basic infrastructure, and this year we are adding to it. This is basically for storage of all CSIR scientific data. Then we also have a domain expertise, scientists with a domain expertise in earth sciences, climate, agriculture, healthcare, etc., who basically, because traditionally we were a computer simulation and mathematical modeling lab, so they use data and do models. So that traditionally is there, and we have a very niche expertise and a very strong domain expertise. So based on that, we have two divisions. One is interdisciplinary data research, and the other one is big data research. So under interdisciplinary, we do have an observation network of GPS stations. Now it is called GNSS, across the real time continuously operating, and then we have broadband seismic stations for earthquake hazard. Then we have GHG, greenhouse gas stations. So we use this data to model. So that is under this, and we also have a climate modeling group, and recently we have got a mission mode project on region specific smart agro technologies for soil and plant health. So that is the, in a nutshell, the domain expertise of 4pi. Other than data science, in data science, we host the supercomputing facility for the whole of CSIR, and now we are also hosting cloud storage, and we are also getting one more system from NSM for ACSIR. So that is also in the pipeline. Then we in-house, we do cyber security and data privacy research here, and domain agnostic AI ML. So that you will see when those people present. Next. So I will not take much of the time, I will just give a glimpse. So some of our major highlights are, from 1994 we were the first to set up a GPS station in 1994 in the country, when GPS became fully operational. So from then we were running that program. Then we were also first to give the earthquake hazard map, because we had a very strong mathematical modeling background that time, the scientists. So we were the first to give an earthquake hazard map, and then we also later on we start ocean modeling also we were doing that time. Then we branched into climate. Now we branched into impact of climate, then agriculture, hydrometeorological disaster, etc. Next one. So this is the earthquake hazard map which we had given to Bureau of Indian Standards. So we give a acceleration on which they can design the buildings, and then we also have the seismic risk map, where individual vulnerability in terms of population density. So this is one of our flagship outputs. The next one is the GPS one, where we had I had set up I was working in GPS from 1994. The next one, yeah. So for DST, that time there was no Ministry of Earth Sciences. For DST, I had set up a network of GPS stations, which later on went to MOES. So you can see on the left hand side, this is all the motion which we captured using GPS, and then we use inverse models, that is, if the surface motion is this much, what is it below the surface causing this motion. So that you can see inverse models for full of Himalayas we have given, saying that this is the slip along Himalayas and this is the strain accumulation. So if based on that we give the recurrence interval of earthquakes. So the down map is for the Kashmir, where we have given strain rate. So here we gave recurrence interval as 520 years with a magnitude of 7.9, probable magnitude of 7.9. Next slide. This is the other one, climate change. Last time when we met you, you were quite interested in this. So we have a presentation on climate change, climate models and all by our Chief Scientist Rajendran later on after your address. So, I will not go much into it. Next slide. So, here we work on climate modeling and impact of climate change. So, this is one of the slides is on the impact of climate change for National Himalayan Monsoon Mission we did, where we gave a prototype for heavy rainfall events to the Disaster Management Agency in Kullu, and we have also conducted workshops and all for them so that they can use that prototype. Next. So, this is our GHG measurement network. This also we have a small demo where real time GHG data collection we will show later on. So, here we have 4 stations. So, what we do is the data that is collected, this is a WMO standard station. So, this is they measure carbon dioxide and methane. So, we collect the data that is collected is again done as atmospheric transport model, inverse model, to find out what are the carbon sources and sinks. So, like you can see the down model. So, using our stations we can show what are the carbon sources and sinks, atmospheric, land flux. So, we can generate this, and this as we collect more and more data it gets improved. Next. This is our new mission mode project, and because nowadays our honorable Prime Minister's focus is on farmers and agriculture. So, this project was given to us as a nodal lab, smart agro technologies, because we are a data science lab. So, we use AI ML techniques for this, for soil and plant health. This started recently. So, our one of our scientists is a nodal scientist, and we have 10 participating labs. NAL, we use NAL's drone and all to collect the data of the farmer field. So, this is very region specific to the region and the crop. Then we give them solutions to the farmers for enhancing their yield, for fertilizer spraying, etc. Next. So, that is as far as the interdisciplinary data science research is considered. So, our research is in this division was showcased at 80 success stories of 80 years of CSIR, and we work in most of the national missions like National Himalayan, National Monsoon Mission, etc. And we work very closely with all disaster management agencies. And this division, basically the whole funding comes from gap projects. Major funding comes from gap projects like MOES, DST, MOEFCC, etc. Next. So, this is our big data research and supercomputing division. You know, when we were a center in 1988, say, we were hosting supercomputing. So, our first was the convex supercomputer in 1992, I think it was. Then from then onwards we continued it. Now ours, I think, comes in the first 5 in the country. The current capability we are having CHAMP. That's what I came to know last time when I visited CDAC. So, we continue to host. Now, we added to it cloud infrastructure, and then AMD donated a machine for specifically during COVID time in 2020, and now that machine is open for users. So, that is also there. And we also have a cyber security, which anyway the test bed, there is a presentation, so I won't go into it. So, recently we started a new project, mission mode claim, CSIR League for AI based industrial manifestation, where almost like 34 out of the 37 CSIR labs are participating. It is basically to use data science for industry purpose. So, here you know the model is like we get, if CSIR is putting 50 crores, then 60 crores industry will put, 40 crores line ministry. It is a combined thing. It is a very good thing which is going to start in this financial year, but the work is all done, DPR is submitted. Next one. So, this project is a data science projects which we are doing, one with Cognizant as partner, security and privacy aspects of vehicular ad hoc network, and then other one is UDAS, where we create synthetic Aadhaar data so that it can be given to users without compromising on the security of the Aadhaar data. So, that also I think there is a presentation, so I will not go much into it. Then we also do, based on the request from CSIR labs, data science specific solutions we provide to them. Next. So, this is cyber security one, which anyway you will be seeing later on. Next. This is our centralized supercomputing facility, photograph which you will be seeing. Next. Next one. Yeah, this is the claim project. This also I have explained. Next slide. Yeah, this is the going forward. Thank you, slide. So actually now whatever we have listed, roadmap and strategy, this was listed around a year back, but most of them we have completed, like, but still I kept it so that like we identified high impact use cases and demonstrated proof of concept. Now we have pan CSIR claim project. So everything we have kind of, this was a roadmap which we gave 1 year back. So today morning when I was looking at it, I was thinking we kind of almost achieved it in a year's time. And on the left hand side, these are all the themes of CSIR, 8 themes. For all the 8 themes, we are horizontal across all the 8 themes. Only thing that is left is we should also contribute to the we should also make a name as a data science lab in the country, not only in CSIR. But that is pending, a center of excellence, so that maybe in the next 1 year we should be able to achieve. Yeah, thank you so much. I think that is all I have to say. Yes.
On the AI side, what is the domain that you are working on AI?
Actually, we have a presentation. Maybe we can, yeah. You asked for 3 when we met you. You wanted to have one on climate modeling, and you were very interested in the cyber security. So we made a very short presentations. It's part of your agenda also, and one on the AI. So 3 we have. Each, yeah, we will cover all.
Thank you, ma'am, for giving a gist of the activities that has been carried out at our institute. Now, before we proceed with remarks of Somanath sir, I request Shri Tangavelu, our chief scientist, to give brief introduction of our mentor, Shri Somanath sir.
Not required, you can Google.
Actually, you don't like a formality. It's okay.
Good afternoon, everyone, and it's an honor to give a brief introduction of Shri Somanath ji. Shri Somanath ji is a distinguished scientist and Secretary, Department of Space, Chairman, Space Commission, and Chairman, ISRO since January 2022. Shri Somanath, spanning a distinguished career of nearly 38 years, has made significant contribution in the area of space technology. Shri Somanath is an expert in the area of system engineering of launch vehicles. As Secretary, he piloted the National Space Policy, facilitated in space, Indian National Space Promotion and Authorization Center, activation and engagement of ISRO with new space actors in non-government private entities and startups. Chandrayaan-3 mission was a great success under his leadership. He left no stone unturned in making sure a successful lunar landing in the South Pole. He plays a crucial role for ambitious Gaganyaan mission for sending Indians to space. Under his dynamic leadership, 2 new launch vehicles, that is Small Satellite Launch Vehicle SSLV and Test Vehicle, were introduced to the country and missions were successfully accomplished. Successful landing experiment of the Reusable Launch Vehicle RLV was another feather in the cap for India towards demonstrating the autonomous landing of a re-entered winged body, which very few countries around the globe have accomplished. In his previous assignment as Director VSSC Trivandrum in 2018, he led the lead center of ISRO. He was responsible for launch vehicle technology development. Under his leadership, VSSC has achieved significant feats like crew escape system demonstration through pad abort test, launch of GSLV Mark III, M1, Chandrayaan-2, etc. He spearheaded the development of critical systems for the Gaganyaan program, development of small satellite launch vehicle, reusable launch vehicle, and air-breathing launch vehicle programs. Prior to that, he had been the director of LPSC, Liquid Propulsion System Center, where he led the team to complete the development and qualification of CE-20 cryogenic engine and the C-25 stage, which was successfully flown in GSLV Mark III D1 flight. In his capacity as the project director of GSLV Mark III launch vehicle, the first experimental flight of LVM-3X CAR mission was successfully accomplished on 18th December 2014. He is a fellow of Indian National Academy of Engineering, fellow of Aeronautical Society of India, Astronautical Society of India, Indian National Academy of Sciences, and Kerala Academy of Sciences. He is a member of International Academy of Astronautics. He has published several papers in journals and seminars in the area of structural dynamics and control, dynamic analysis of separation mechanisms, vibration and acoustic testing, launch vehicle design and launch services management. Thank you, sir.
Thank you.
It's an honor to have you here.
Thank you, Velu, for that introduction, and thank you, your head ma'am. You call her head ma'am. It's not. It's also very interesting. And all the scientists and staff of the 4PI Institute, really happy to come over here and then coming to know of your work. See, I'm excited to understand you first, not really to give any advices to you, and possibly to understand who are the users of your work. And finally, whatever you do here, it must become twofold outcome. It has to be one, it has to really help you to grow as a scientist, knowledge-wise, skill-wise, create an institution-wise. Second, as CSIR mandates, it has to really benefit the society in which you live. So who are the people who in the society that you are targeting? This is something which I would like to understand. And whether the targeted delivery of what you are doing is happening, that is something which I would like to understand. And if that area, possibly I can help you, because I can't help you in your individual growth. That is depending on each one of you. Your work, your expertise, your ability to learn new things, change with the times, all of that will decide who you are going to be with the times. But at least on the other side of it, possibly as a mentor, I will be able to help you, and then possibly to show some examples from other places other than this institute. I know you being a small institute, you have a lot of advantage, but also equal disadvantage, because small thing means everything is known, everybody is in close community, close working together. But when you become too big, you don't know what is happening around, and you get lost in the whole of this, and a lot of duplication of work and things like that happen. But a medium size would be a right size. I think possibly you may have to grow to a reasonable size to say that you have reached that threshold for what is mandated to you. One of the important point while building new organizations and new facilities or new labs is to be aware of the goals and size. Don't have to too much go into too many lateral things and then create a problem for yourself little later. So I believe that leadership today and people who are here, especially youngsters who are likely to join now, will be aware of those aspects, very important for an institution to be developed. This happens in the history of any institution. Digression of goals is something which is very dangerous. From the community that I am coming, ISRO is very, very focused. It will do only that and nothing else. So this helps us in focusing on what you want to do, and don't allow anybody else to do what you are doing. So that's also important, because don't allow anybody else to develop rockets. Only we will only develop. But that is also changing. Today I am asked to develop private companies to build rockets. So that is again another big challenge, and it is a psychological shock to many of my my colleagues to understand this change of narratives. It took time for them to understand it is important for us to do that also. So now coming back to your domain of expertise and domain of work, and many of them are equally important for us as well. That's why I was interested to find out how you work in the climate research, because we have a very strong community within ISRO who is working in climate domain. I think some of you may be knowing already through your publications and the work, or maybe familiar with the people who are working in that. To tell you that we have space physics groups which is actually working in that domain. We have one at Trivandrum called SPL, space physics laboratory, which has scientists who are working in atmospheric science, space weather, and all those domains. We started from the sounding of the atmosphere. That was the beginning of the space program. So measurement of the atmosphere was the space program, and then we have one at Bengaluru in the satellite center. We have another space physics group which is working on it. Then we have a program called NISES, which is hosted at Hyderabad, and also a national research laboratory again at Hyderabad, which works on the upper atmosphere studies, NARL. So all of them together form the atmospheric research group at Hyderabad. Then we have one at Ahmedabad, Space Application Center, where they also build instruments primarily for measurements which are hosted on satellites and do the atmospheric parameter measurements. Then we have another institute at Indian Institute of Remote Sensing at Dehradun, which also does the large amount of measurements and also do capacity building. We have one at Shillong, which is the Northeastern Space Application Center, which also hosts huge amount of ground-based instruments for measurements. And all of them do a lot of ground-based instrumentation. We put up flux towers, ground-based measurements. We also conduct campaigns at Himalayas, sea trips, etc., to collect a lot of data. And over the last so many years, huge amount of data is created. We also have portals. Possibly you can go look at the weather atmosphere-related portals which we give. We do space-based measurements quite a large in terms of the essential climate variables. Something like 12 of them are being measured from space, and we give it to Ministry of Earth Science, which uses them for modeling. We have also data collection platform across the world, across India, and we are mandated to collect it through satellite and deliver it to IMD, which is again another task which we do. So for that we have payloads in satellites. Recently we have launched one, INSAT 3DS, possibly you know, which takes images, sounding of the atmosphere, measurement of vertical temperature profiles, wind vectors on the sea. All of these are done as space-based activities. So it's something very interesting to look at the climate scientist and then understand how they can complement. Of course, we have a lot of connection with institutions like the one at Indian Institute of Science with the Devecha Center and many other institutions across the country who is working on climate and weather modeling. So you maybe really want to understand deeper into it and maybe connect some of them. Possibly you are connected, I do not know. Cybersecurity becoming more and more important for us. I think I am threatened by people like IB and all on a regular basis. They come contact and audit, and we find a lot of problems with us. We have huge amount of network in ISRO. I think your skill and your capability is very much needed. Actually, in fact, we are looking to create a SOC soon in our facility to create an entire network watching and to see the activities each and every individual, what they do, and then really take protective action. Today the country is facing so much of challenge in terms of cybersecurity. They are everywhere. Just now before I come, I had messages from top institutions on what all things happened just now, which requires some of the individuals are targeted. So I want to tell you that everybody is under scanner. So it is something very important, and we must develop that skill sets. We must deploy huge amount of people in this area, because the future protection of our assets, wars are being waged in that domain. So it becomes all the more important to have that capability in this country. It's not for institutional capability, it's something that need to be shared, nurtured together, because a lot of people have to work together to create a national skill set of cybersecurity, both offensive and defensive. I think this is something which is very, very important. AML, I don't have to give a lecture on you, lecture to you. I think it is everywhere. Just now only I installed the new AIML tools in my mobile phone. So, which is really interesting to see how things are evolving with the times. So, we also have huge amount of AIML activity within ISRO, which is actually spread out. Possibly, you know, our Gaganyaan program is again going to be AI driven. We have a lot of onboard intelligence to be created based on data. We also have space-based data being with a machine learning. We are improving the pattern recognition, object identification, etc. Those activities are taken up by this machine learning and AI tools. We also have edge computing on board on satellites. We have deployed some. We are going to do more, so as to do processing of the images also on board and send only the necessary information, not the entire image, so as to reduce targeted data transmission minimization, which is again a major topic. Quick decision based on imaging becomes very important, and for that you need these tools. One of the example which you saw, every rocket launch possibly we cover the entire rocket using cameras, and even a small leak comes, that is detected by our AI tool developed. Even gas traces comes out, it is possible to detect and then come out using such technology, which we are deployed for many launches now. Because one day once we had a leak problem, we couldn't understand what is actually leaking. The whole launch has to have water. Immediately we created that tool on high resolution camera based detection capability, which is again based on a lot of machine learning algorithms. So this again gets into every engineering activity now, in drones, in control systems, everywhere we have so much of AI related work. Even NDT, X-ray imaging, AI machine learning tools are being used to understand defects. I think recently I heard even our chest X-ray, you can find out TB. Earlier, no, even just from a chest X-ray, it is not possible to find out the presence of tuberculosis. It requires much more skill. So recently, an AI tool has come out by a private company in India, which is going to be available with every doctor now. If you get an X-ray, just put it in the machine, it will scan and compare with a huge amount of database to check whether this particular X-ray gives an indication of a tuberculosis. It's really great finding. It will be really such a strong tool in front of the doctors, if you can help something like that, which is very high impact on society. Just doing an AI activity on an X-ray of a chest, because otherwise tuberculosis detection is a very cumbersome process which takes months of testing. So there are many things that you can actually do based on these three domains itself. So I'm really happy to see skill sets, though they are limited in numbers, but you also know that there is a huge amount of equally strong team outside this institute. I think this is something which you should be aware of, and never work in silos, never work in isolated domains. Connect with everybody in this country who is working in this domain, be aware of it, and I will be happy to facilitate whatever is required. But I am not going to come forward and tell you what is needed, because it is that is not what is expected. I will also want to make sure that it is not me alone is represented as Secretary of Department of Space here, Chairman ISRO, but the entire organization is represented by me here, and they are all happy to be mentor of you. Okay. So our scientific strength is 8,500, so it's huge, but it's less than CSIR. It's only 3,000 scientists. Okay, okay, okay. That is 3,000 only, but other strengths are high, total. Yeah. So 18. Yeah, I know it is higher than ISRO. Our strength is only 17, so it is less than.
Ours is only 7. Yours is 18.
Mine is okay, 17,000. Okay.
Ours is 7.
Okay, it is total CSIR plus that DST. Maybe it is.
No. CSIR only 7.
7 only. Oh, okay, good.
That's the problem, because there were no recruitment. See, our sanction strength is 18.
Okay. Sanction strength is 18. Correct. You never got it filled. Okay, fine. So anyway, that doesn't matter. The strength is only one measure of the strength of the organization. So I'll only tell you that there is huge amount of caliber capability in organization like ours, and we'll be happy to connect anybody that you need it, and any support that is needed to build anything for yourself. We'll be happy to help you, and there are without any complications, no governmental ways to come in between. So suggest is, as long as I am able to connect with you, I should be able to help. Thank you so much.
So thank you very much for sharing your insights and experiences and words of wisdom to the family members of CSIR-4. So your introduction, okay, of course, as you said, it's not required because all the Indians will be very well aware of it, but it's only to refresh about your latest laurels that you have got, sir. For our purpose, we have given your introduction, sir. And as you said, we will try to remain focused. We'll try to remain focused, and we'll make sure that we don't allow anybody to trespass into our data science activities. That also we do, sir. Okay. Now, before we proceed with the next program of PPT presentation by a chief scientist, I request Head Ma'am to please accompany Somanath sir on to the. Please.
larger screen.
Yes, ma'am. I request Rajendran sir, our chief scientist, to present the PPT on climate modeling.
Okay, good afternoon.
I'll do one thing. I'll go to that side. So I can see your face and Somnath's presentation. And shall I take this seat?
Yeah, I think I'm audible, so I don't want to use the mic. Okay. Sorry. Come back. Okay. So I directly go into the slides. My name is Rajendran. Okay. This is the summary of climate models. I think I'm audible. Yeah. Okay. So in this slide, I am summarizing all the climate models or weather models or climate change models which we are using at CSIR-Fourth. So for different applications, what you can see that for the climate regional projection, we use very high resolution global model, which is of the order of 20 kilometer across the globe, which is very few across the world itself. So that is
This model is built by you.
this is by a collaboration, because I was also part of the developing team with MRI Japan. So when I came to join this institute, we had an agreement, and then we have installed the model here.
So it is fully available to you to modify.
Yes, it is available. And but the problem again, I wanted.
You can have much more finer model locally.
No, the problem with this one is scientifically we are restricted with the 20 kilometer resolution, because beyond that we cannot go because of the hydrostatic approximation. So for that also we have came up with an alternate solution. Okay. Yeah. So we have came up with an alternate solution, because when we wanted to study the climate change over a local region, for example, a city or a then we can, the 20 kilometer is not sufficient enough. For that we have implemented a dynamical downscaling framework in which we can go up to 3 kilometer. But it has a limitation, because we have a global model in which we have embedded a regional climate model into it. So then this is covering the climate change aspect. When we come to the seasonal prediction or monsoon prediction, we were part of the MOES project of monsoon mission, and under monsoon mission we were able to install the monsoon mission model called CFS-V2 in our center here. We are the only center other than MOES is running this model. And but our aim is not to do any the forecast or anything. We are only improving the understanding of the model and improvement of the model. We are working towards that aspect. Then we also do study the aerosol impact on the climate. For this we have collaboration with the VSSC, especially the SPL team. They have a project under GBP ACE program. We assimilated those AOD observations into the model. But this model is a system model which will be very comprehensive, which will have geophysics.
It's a global model.
It's a global model. And but the resolution is not very coarse. It is about 100 kilometer, because our aim is to see how this aerosol is altering the climate.
You have ability to look at the transport phenomena, etc.
Yes, we do have, because we also have an individual transport model, SAR, which that also will be used for the transport purpose. But our basic understanding is how this aerosol impacting the monsoon rainfall or monsoon climate. That was our major focus. Then we come to the weather forecasting. We also have a Florida State University global weather forecast model, because that is purely initial condition problem. So which is but it required a very fine resolution actual observation. So one of the work which we have done under ISRO's megatropics project is we have assimilated the rainfall and temperature along with water vapor profile, and to see whether the 3-day forecast is improved or not.
No, megatropics no longer there. So what is
Yeah, even we had a problem when we come to the implementation stage because the Madras sensor failed. Because of that, we couldn't use the rainfall, but we have used the rainfall from TRIM because it was coinciding the similar period. But we could use the temperature data and Saphir moisture profile from Megatropics data. Yeah. Can you go to the next slide? Okay. Okay. So I'll quickly, I will not spend much time. This will be showing that how the anthropogenic effect is affecting the climate and variability, either through change in the atmospheric composition or through the land cover change. It's all interconnected and complicated. But I wanted to put an example here. As we know that the world energy supply is required by burning the fossil fuels because most of the component is here. What is the end result? The increase in CO2 which is loading into the atmosphere. So this is the last 60 years CO2 observed over the Hawaiian island. So, so corresponding to the CO2 rise, what you can see here, the global average temperature is also increasing, especially towards the last couple of decades. So this is the present scenario. So if you wanted to ask me, the question is what will be the future change? Okay, then we need global model to do that.
But is it correct to say that global average was lower, coming down annually in the previous?
Sorry. No, no. Yeah. So
Yes.
because this is the base period we usually used to take the climate average, that is from 60 to 99. So within that you will have a local year of fluctuations. But if you see if you avoid those periods, you will have an epoch of lower temperature, and now if you have a very sharp rise in temperature, this is an anomaly. You can see that it's already closing to 1.5 degrees centigrade. So what my point here is, if you know the observation, if you want to project to the future, the only tool is global model. Okay, so this is the present status of the global model across the world. We do have around 66 modeling group all over the world, and this is starting from 1990s to present. So we do have the IPCC, under IPCC we have CMIP 3, CMIP 5, CMIP 6. What I wanted to show here is from CMIP 3 to CMIP 6, we are still at 100 kilometer resolution in globally. This is what the state of the art model available now for the climate projection aspects. So one important aspect I want to highlight here is the monsoon simulation, especially if you use this global model and see how the monsoon simulation from the 70s to present. The observation is the gray line. You could see that the mean is more converging. That means there are improvement in the model. So, and also why this resolution change? The resolution changes because we do have a better computing capability from the last 30 years. Okay, and then recently there are a couple of modeling groups started developing very high resolution model. So one of the model which we have developed at MRI is 20 kilometer resolution. That is what we are using for the climate change projection. Okay, so before taking this model for projecting, we also would like to know how this model is able to simulate the present day climate, so that once you get a reasonable present day climate, then we will give the projection with less uncertainty. So this is the one of the example of which we called as something like a 50-year climatology from the observation, and this is from model. By and large, this model gives far better present day climate simulation. So, and once this much of sorry, no, it's again, yeah. Yeah, so once you have a confidence in the present day model, then you can take that model, integrate to something like next 50 year or next end of the century, what will be the temperature or precipitation change. So what I have shown here is the state of Kerala and our Karnataka. The initial these two figures is for present day, but this is for the future projection. So what future projection so far known to us was, over the IPCC model says that over India, entire region there is an increase in rainfall, but it is not true. First time about 20 years back we reported that over the west coast of the Indian region, there is a drastic reduction in rainfall. Later, from observation, it has been shown that this is observation shows that there is a decreasing trend over the state of Kerala and over the west coast region. Okay, so when we come to the local, the global warming on the local effect, it is always to worry about the processes. It's not only global processes, it is also local processes important. For example, this is the 10-year average, the daily temperature variation over the station over Trivandrum. Okay, but so what you are seeing here, the blue to red means there is a constant increase in the warming. That is basically coming from the global effect. But there are some particular year, for example 2016 on May, there was an extremely hot days, which is even now this year also is observed over many places. That is basically, we cannot relate directly with the global warming or climate change, but there is a local process. For example, Bengaluru, the urban island effect or the heating effect, those kind of thing also needs to be considered. But our general circulation models at 20 kilometer resolution may not be able to capture this local process. What we need is further high resolution. So that is why we have formulated a framework in which we embedded a regional scale model into a global model, because we have seen that our global model is capable of simulating the mean climate very well. So if you have this kind of a framework, if you can see the west coast of India, where we got considerable reduction of rainfall in the future projection, so the orography over that region is well resolved at the 3 kilometer. So once you have such high resolution climate projection available to you, you study the extreme rainfall variation or the extreme hot events or wind extremes, warm cold nights, how this is changing with the climate change. So what is most important I want to highlight here is, as I showed, the climate projection over the west coast of India shows a considerable amount of reduction in rainfall, but the temperature is increasing. So it's a very peculiar case where you get warming and increase in consecutive dry days, and the winds are stabilizing, then the rainfall is reducing. In such condition, what will be the application? For example, we have taken the crop yield. So this is a controlled station at Manuti, where we have done a field experiment, and also we used the crop model, and we applied our the climate model output and see how much percentage of crop yield can change in a controlled environment. We have found that about 15 to 20% reduction in crop yield can happen. And another important aspect over this region, because this is a very much biodiversity sensitive region, so we need to study the land use change. So what we have done is we have changed the land use pattern, and in the changing the temperature and rainfall scenario, we have found that 20 to 40% of vegetation, the evapotranspiration from vegetation is contributing to monsoon rainfall. And another aspect is over during the extreme rainfall events, like for example 100 millimeter per day rainfall, if it is happening over the region like Kutanadu, that is the region which is very close to mean sea level. So then how much of area can get inundated? So that map also be generated, and recently we have started mapping the drought severity zone over the Kerala state, and especially over taluk level, because we do have a very high resolution model. So now we come to the seasonal prediction aspect. So for this we use the coupled model. This is the monsoon mission model which Ministry of Science is using, which is having atmosphere, ocean, land and sea ice model. So what we have found that the Indian monsoon, this is shading is the rainfall pattern. The Indian monsoon is very much correlated with the surface temperature, ocean surface temperature over the Pacific region. For example, this year, this is 2024, we are right now on the warmer, the black line shows the average temperature over the Pacific, the eastern Pacific. Then this is already, we are in the warmer condition, which is called El Nino like condition. But all the models, even our own simulations here, shows that end of the June or July, the temperature is dropping and we are going to get an El Nino like condition. Then what will be the advantage? We can have a very good monsoon rainfall. But our own another study showed that the error, because this is also depending on the initial condition. So initial observation is also crucial. So if the error will be minimum, if you start the forecast at the late April or May, so which observation has to come? So we need to see whether the similar La Nina like condition is going to stay or not, whether we are going to get good monsoon or not. So this is the kind of work which we do here.
But this data outcome, those were
We had a project with
MOES
MOE.
MOES takes it?
Yeah, MOES, because especially the finding like the initial condition, because we need not run the model for all possible initial conditions. Instead, we use only the end of May and beginning of April set that will have more skill. So that is why even monsoon official forecast will be going to happen only end of April.
This you said about the ensemble. If the ensemble which are the other models coming in.
No, this ensemble is the same model with a different initial condition. Because every month we will be running the model with 5 days apart. So you could see that it is starting from different time in the 5 February, 10 February like that. Okay, this is the a slide which I want to summarize the impact of aerosol in Indian summer monsoon, but we have done using an NGAR system model. So here we have studied the aerosol direct effect as well as indirect effect. In the aerosol direct effect, we have known that if the scattering aerosol is more, then it can suppress the monsoon rainfall, whereas if an absorbing aerosol is present, it can intensify the rainfall. But the secondary effect, when if it is having a interaction with the cloud, then the more cloud condensation nuclei will be available. It can make the cloud stay for longer without precipitating, so it can also reduce the rainfall. So the end finding is that if there is a dust aerosol is more, then there is a chance of less rainfall over Indian monsoon. Okay, this is when we come to the weather forecasting part. This was done with the megatropics.
Surprising finding, but that's not what I have read somewhere.
Okay,
Whether the decreasing dust aerosol it actually contributes to reduction in rainfall.
rainfall. Yes, that is what we have. When it has been published also. Yeah, and even VSCC team also is part of this work.
Same conclusion.
Yes. They are also co-author of the Dr. Krishnamurthy is part of.
Okay.
Okay, so in this this is what I just this is the observation. Once you utilize the satellite-based observation like megatropics, moisture as well as precipitable water vapor, and to trim rainfall, then if you don't use the assimilation, the 3-day forecast will give some spurious rainfall events like this. It is unrealistic because not seen in the observation, but if you do assimilation, you can improve the 3-day forecast. So this is the future roadmap, because as I said, we came up to 3 kilometer resolution, but still that has its own weakness because we are using a regional model which is embedded to a global model. It will be boundary forcing will be an important factor there. So if you can have a global model with 1 kilometer resolution, then we can expect, we don't need a cloud parameterization. Cloud will be already the cloud resolving model. So this we were working in collaboration with the University of Tokyo, because Dr. Masaki Sato is developed a model here in this. So but the model is not yet implemented here. It is, but we are only collaborating and working with the data, and the initial work is also published. And another aspect which we are also trying to put now is the projection of extreme events, because extreme events are very rare in number. So then if you use different model and AI algorithm, especially the hybrid type of AI with the physics guided algorithm, then we can have a better reliable projection of extreme events. So this we have working in collaboration with IIT Bombay and IIT Gandhinagar, and it has been a center of excellence in the AML and climate stream has been got approved, but funding is not yet received, but we are expecting from NRF in the next financial year. And another requirement from the Kerala state government is that we wanted to construct the drought severity zone, because the rainfall over Kerala is reducing a lot in the climate sense. So then they wanted to know, for the policy decisions and policy input, they wanted to make in taluk level how this the drought severity zones, if we can identify and map, which can be used for the government policy decisions. So with this I would like to stop. Thank you.
So how do you run this model on what type of periodicity or whatever you have to know?
Yeah, see, for example, if you want to do aerosol simulations, we need century scale. That is about 100 years of simulation. For multiple multiple use of different species of aerosol. So you will have minimum 5 or 6 sets of century scale simulation. And if you wanted to see the climate like monsoon simulation, that is only seasonal, 9-month simulation. But we have multiple ensembles, different ensembles will be used. And for climate change, we will be using, because the high resolution model we cannot use for continuous run for 100 years. There is no resource for that. So we do employ a time slice methodology, in which we have a present day for 25 years, near future 25 years, and far future 25 years, like that. Okay, thank you.
Thank you, sir, for giving us a brief about the climate change, weather, as well as related studies that's been done at our institute. Now I request Dr. Anil Kumar, our Chief Scientist, to please present his PPT on cyber security.
So good afternoon. I am Dr. Anil Kumar, and it's indeed a privilege for me to have this opportunity. To have this opportunity. Yeah, I can do that. Yeah. No, I will be fixed here, wired here. Yeah. Yeah. So this presentation is about the cybersecurity research and observation program that is being done at CSIR-Fourth Paradigm Institute. So I would be focusing more on our effort towards the indigenous design, development and deployment of a cyberspace surveillance mechanism called a network telescope. And the objective of this is to gather threat intelligence by watching the overall cyberspace. So as we all know that the cyberspace is growing very rapidly.
How many people work in your group here right now?
Yeah, as a scientist I work. I also have some contract staff and all. So the development is largely done by the scientist, that is me. Plus I have 3-4 staff explicitly hired from a project for this purpose. Okay. So we all know that the cyberspace is growing very rapidly. There are already several billion hosts or devices, and we call it as a cyber citizen sort of some devices. And there are also several millions being added on a regular basis. So this ecosystem is growing much more rapidly than what we thought. So from a security perspective, they can be very broadly divided into 2 categories, good machines and bad machines. In fact, we also know that there are well-established network of bad machines called botnet sort of scenario, which is readily available in the cyberspace, which can be exploited to launch attacks against anybody. So there is a very important, it has become very important national requirement to surveil watch the cyberspace, gather intelligence, and then use it for policy sort of decision making, including how to protect the network sort of stuff. So this is we are contributing to that mission, and this is being funded by Ministry of Electronics and Information Technology, and it is for a strategic sector where the stakeholder is Computer Emergency Response Team and National Cyber Coordination Center. So these are typically 2 agencies. They are responsible for watching the Indian cyberspace and give advisory to government, and at the same time give. Yeah, you're familiar with that. So the whole idea is that the cyberspace surveillance framework needs to be based on indigenous mechanism as much as possible. So we are contributing to the national cyber threat platform of Computer Emergency Response Team by indigenously designing and deploying a framework called network telescope. So this is a mechanism by which you can watch the cyberspace by and quite similar to the conventional telescope, and we can have few centralized location and then watch the overall cyberspace and then try to find out what is the security dynamics and what sort of actions are required. So worldwide, security researchers and policy decision makers are deeply involved in designing of network telescopes. So I just highlighted some of the most important things here. So network telescope at CIDA is the Center for Applied for Internet Data Analysis, is the largest network telescope in the world with a huge IP address space and so we are also, CSIR-4 also is running a network telescope now. So I will get into that. Yeah. So from a technical point of view, what is a network telescope? It's a globally routed and valid IP address space, which is not assigned to any particular host or device. So the IP address is valid, means if a packet is placed on the internet, destinated to this IP address, it will travel through the internet, but at the same time, at the receiving side, there is no host which can receive this. So the whole question is that why do we see such traffic? Because there is no host as such. So under an ideal scenario, we are not expected to see any traffic coming to that, because it is almost like a parcel coming to a person which he has not subscribed to that, or a letter coming to an address which is never existing, sort of stuff. But real world measurement or fine grained analysis on the internet traffic shows that we receive such traffic which is called internet background radiations, and they are primarily due to the security dynamics on the internet. So these all are some of the security related activities on the internet that triggers the so-called internet background radiation. So a network telescope is a framework which will capture this traffic, validate it, and then subsequently find out and extract threat intelligence out of that, which can be shared to the common platform so that others can also use this for detection, mitigation sort of scenario. So this is being developed, I mean, this is a Python based program which is being developed at CSIR-4. So the entire coding is done locally here, and we have basically, three modules, which functional modules, they interact each other. One is called a sniffer module, and then there is a responder module and a validator module. So I'm not going to the technical details of this, but I would like to show some of the results. So when we deployed this network telescope in our CSIR-4 network test bed, which is located at the ground floor of this building, and we could see that something like 0.95 millions of unique IP addresses from all over the world connected to the network telescope and try to interact. So this is for a period of 2 months starting from 2023 November till end of the year. So it is also interesting to see that the graph is constantly increasing. This shows that each day we get new IP addresses connecting to our network telescope, and we are able to monitor them. And they belongs to something around 13,000 unique families. So each IP address can be mapped into, for example, all our IP addresses will be displayed under National Knowledge Network. So like that, they belongs to 13,000 plus IP address family all over the world. Now, one important thing is that we run an active network telescope. Conventionally, a network telescope is just a passive device. It just receives the traffic and then try to analyze it. So we have made it slightly responsive so that it communicate with the remote host. And this also enable us to get certain extra information like additional payload. So out of the 0.95 million connections, or unique IP addresses, we could see that about half of them, 0.5 million unique IP addresses, in fact communicated some payload after connecting to the network telescope. And this is the corresponding family from which they belongs to. Yeah. So this is the geographical location all over the world from which our network telescope sees the connections are originating from. So we did a number of analysis. So one of that was actually to pass this through a high pass filter. So what we did, our intention was actually to find out more serious and more aggressive guys in this. So this graph shows actually location from where we got a, this graph shows the location from where we got more than 10,000 connections, and then we strengthened the filter further and further, and then we could see that even if you look for something like a location from where more than 1 million connections are originating, we do see such network existing in the cyberspace. So they are very persistent in terms of trying to recruit new and new machines into their network, which can be used for exploitation and attacking somebody at a later stage. So if you look at on a daily basis also, the telescope has been receiving something like about more than 2 million connections, which is much higher than the connection that is coming to a production network. So there has been substantial amount of internet background radiations and then connections associated with that. So there are number of observations that can be done through network telescopes. I am not covering all of them, but one particular scenario which we could identify for the first was a particular case of spoofing. Typically, we all know that IP addresses get spoofed so that the identity can be hidden, sort of stuff. But this is a scenario where actually the packet length is spoofed. We could see that here is 4148. At the same time, the total content of the packet is only 1486, sort of stuff. So these all are newer strategies of the attacker by which it is trying to see whether it can exploit some of the vulnerabilities of the operating system. So more interestingly, from a surveillance point of view, what we could see is that this is being done by a network of hosts which could be mapped, and this is their physical locations are displayed here. So we would call it as a sort of a organized botnet which is involved in this sort of activities and trying to collect information which could be used for an attack at a later stage. Yeah. So as I mentioned, this is being done for certain computer emergency response team. So they are actually in the process of building a national cyber threat intelligence platform, which actually depends a lot on diverse amount of cybersecurity related data flowing to them, so that this data can be processed and then alerts and warning can be issued to the country. So we also provide input to them, and we generate two type of feed from our network telescope. The first one is a human readable feed, which is more for a policy decision makers, typically like a PDF document sort of stuff. And the second, and this is now generated on a daily basis. And the second one is machine feedable stuff. I mean, it can go to their processing engine directly, and can be number crunching can be done, and then output can be used for producing alerts. Yeah, so that's all. So no, I'll speak about it because that slide wanted some more modifications, so I didn't do it. Okay, yeah. So our future plan, there are two things. One is that we wanted to continue to develop this further because this framework is non-existent as of now. So we'll continue to do that. And we also wanted to hand it over to CERTIN in such a manner that they will establish a network of network telescope in the country, so that the data would flow from multiple locations, and then that can be crunched for a more meaningful information. We would also look at this telescope data from a different point of view. For example, you know very well that the cyberspace is expanding from the Earth or land to the satellite, and this one, for example, to moon also probably, yeah. Because a lot of LEOs were launched in the recent past. I think ISRO also launched some of the.
China launched one satellite.
Yes. Yeah. Okay. So there was some LEO satellite launched by ISRO also for OneWeb, right? For OneWeb? Yeah, LEO, correct. Yeah. Initially it was 36 plus, then I think it was additional. Okay. So and Starlink has quite a number by 5,000. Yeah, there are Starlink. Yeah. So yeah, Elon Musk's one. Yeah. So it is part of the SpaceX and then related. So one thing that we wanted to see that whether our network telescope is able to see traffic which is being routed through this satellite network.
Right now, not possible. Because
They protect it, but at the same time there are side channel information like their autonomous system number, ASN number. So I can map that if particular packet, because we also do a validation of the IP address. So if I can map that this is coming from, for example, this particular ASN, Starlink operate only with one ASN. That is what I showed as a family in the right side of my graph. So those sort of scenarios will give us a better picture whether the internet infrastructure deployed in sky is also being a target for this sort of activities in future. It is going to be, yeah. It is going to be. The initial measurement trend also shows that it is going to be, yeah.
They are making a lot of attempts.
Yeah.
Even with our satellites.
Okay.
So a lot of attempts spoofing has been done.
Yeah.
So we are hardening most of the command lanes. Now we have to bring in quantum encryption.
Yeah. Yes. Yeah. There is no other way. That algorithms are much more robust in the map.
Okay, but whatever you are deployed here is able to look at the entire internet
Yeah,
space.
because it look at the entire internet space. The reason being the process is a random process. Most of the search done by this malicious hosts are a random process. So the outcome of this, whatever I call as the internet background radiation, they are scattered across the internet. So even if you look at a smaller portion of the internet, you get a sub portion. So we initially deployed about 200 sensors for this purpose. Now got a dedicated set of IP from IRIN. IRIN is the Indian registry for, and this is exclusively for telescope. So we are upgrading the telescope to something like 500 unique IP space. So we expect to see much more traffic, whatever.
This can it be deployed in the standalone networks?
No, it needs to be connected to the internet. Yeah. Oh no, it can be actually for the large corporate network. Yeah. Yes, it can be. Yeah. For example, if within ISRO also, if there is any machine infected or yeah, it can be. We could do that. We could do that. Only thing is the two requirement. One is that we need a permission to sniff your network. Yeah. So this is, because this is yeah. So without that we cannot do that. So sniffing is essential, and then yeah, it can be yeah. And it can be located inside also. Yeah. And in such case, probably this active response itself may not be required also because it is a closed network. Yeah. We need not respond. We can only yeah. Yeah. In the case of internet, it needs to be active also because there is a potential chance that other side would be spoofing his identity. Okay. Yeah. So thank you.
This is a lot of things I would like to bring connection to our problems.
Okay.
Possibly.
Okay.
You will be able to solve some of our problems sometimes.
Yeah, would be glad to do that if possible. Yeah. Yeah. Yes, yeah. Thank you.
Thank you, sir, for throwing a telephonic approach on cyberspace surveillance for threat intelligence. And now I request our Chief Scientist, Dr. Patra, sir, to give his PPT on AI and ML.
Yeah, good afternoon. I'm GK Patra. I will take you through the journey of AI that we had in Fourth Paradigm Institute. Hope I will be able to answer to some of your, like, you were expecting some things, so I will be able to see that. So this is typically the AI portfolio of CSIR-Fourth PI, which I divided into 4 different phases. We started way back in 1996 for a where we started working on a long-range prediction for rainfall pattern. Mostly it was kind of a hobby. It started with like a hobby, and the other one is my PhD work, where we started working on. I have done my PhD on microstrip antenna design. So
I was wondering why that came in this list.
Yeah, because basically people started talking about data science institute, and in 2013 we became a data science institute. Then the 4th phase is where actually right now we are in, where we started using AI for various applications. So we have applications in agriculture, we have applications in security and privacy, we have applications in healthcare, and again we also strengthen our domain agnostic AI framework. I will talk about this portion little detail in my next slide. And what we look at in our future is about how AI is disrupting the total scenarios. But our aim is not to use AI as a black box, but use it as in a responsible manner. Look at the physics-based AI, physics-influenced AI, and explainable AI. So those are the things that we are planning to look at. And our main goal is AI for science, which typically is now called as the 5th paradigm of science. Yeah. So this is the 3rd phase where we really started using AI into different fields. So I'll start from the clockwise direction. So during the pandemic, when the COVID started to start, then there were lots of discussions about working on predictions and other things. So being from the Data Science Institute, we are expected to do some work using AI, ML and all to do some predictions thing. And we, in fact, Dr. V.K. Paul, who was the chairman of the task force for the Prime Minister of India, he used to have regular meetings with us to find out. So we used to give the all India outlook, basically like when will be the peak happen, when will it come down, what will happen, such things, not like a daily predictions. So he used to appreciate our work, and also we gave actually Karnataka and Bangalore predictions on a daily basis. So we were actually sending our predictions to the government of Karnataka so that they can look at how, like, to plan their policies and other things. Then we have publications related to weather influence studies, how weather has influenced the COVID pandemic and other things, and we have a number of publications in that direction. The other work that, as I told you, we have worked on the domain agnostic AI framework, where we have application into multiple domains, but the techniques and frameworks were typically similar. So this was actually part of the PhD work by my colleague, Dr. Asa, who did her PhD, and then we worked on various Earth and oceanic atmospheric science of things, mainly station-based wind speed predictions, which can influence the wind energy generation and other things, like chlorophyll prediction, which will talk about the ocean productivity. So those are the things, and then also crop yield prediction. So we worked on most of those things, and we are actually started an initial work on the ground motion also, whether we can get some precursors from the ground motion data, because Dr. Parvez has lots of huge amount of this ground motion data, whether we will be able to find out some precursors. Then under the AI mission project, we have, that's from the CSI, we have security and privacy of VANET, Vehicular Ad Hoc Network, which are typically something which is still futuristic for India, and it has like lots of interest from industry. So we worked with Cognizant. Cognizant, in fact, funded a project for which we actually gave the output. Right now we are working on a 5G VANET, because earlier was a DSRC based VANET. Now we are working, and also we are looking at to move to 3D mobility, typically to FANET kind of thing, where whenever there is a multiple tenant transportation system, we would like to see whether we will be able to look at the security and privacy aspects. That's our major goal there. Then we have a flagship mission project, I think that already Dr. Sridevi has talked about, which is on agriculture, and multiple scientists are working in that, and lots of, I think it's in an initial phase, and then lots of data is being collected for this project right now. Then the last one is basically all these things are actually applications of AI we used to, but this one what we are working on is directly on AI. How do we secure an AI, or we improve the privacy aspects of AI? And this work actually we are doing along with the Aadhaar, the UIDAI people, where we are, and as you know, like generative AI is the buzzword right now. So everybody uses it, and we use the GAN model, the generative adversarial network model, to create synthetic biometric data, which can be used for third-party software development and other things, so that we don't that the privacy of the data is preserved in that. So we use something called differential privacy and federated learning to set up all these things. As part of that, in fact, some of the results, yeah. So we created, actually we used a GAN model, which is a generative adversarial network model, and created these are the generated images, while these are the original images. You can see like quite similar to that, and these are typically nowadays, like people look at how Rama was looking like, how Sita was looking like. It's the similar kind of work that we have done, but this has an application. It's an application where we can use this for a third-party software development for a citizenry services. One more thing about the VANET, what we did is, in fact, when we were working, we wanted a specific type of data. That's a multi-view Indian traffic data set, which we actually started now we collected that, and it's kind of one of such data. It's a very noble data which nowhere in the world also available, where you can have a multi-view traffic data set, and this is right now there, and we are working on it for various other projects. So as the CSIR, as Dr. Sridevi said, that we are not an individual institute. As far as AI is concerned, we are horizontally located across CSIR. So we have created the whole AI ecosystem in that sense. So we have a centralized cloud storage called Mega, very recently installed, and we have a HPC facility, CSIR HPC for AI and ML platform, that's called CHAMP, which we will see a little later. So there we have lots of AI capabilities. Then we have all these tools and frameworks available for AI kind of things. Then the people. So people not only at 4th PI, we have people across CSIR, and also we collaborate with many people. So collaboration is our DNA. So we work along with most of the academic institutions, line ministries, and other industries. And one of that collaboration has resulted in this league of CSR League, where 34 labs have come together to work towards a kind of helping the industry for industrial transformation through the strategic integration of AI, but with and informed and guided by scientific principle. That's the important thing, because CSIR has that strength, the scientific principle, the way science has to be done, not as a black box. And our aim basically is that we can create a Indian leadership in AI. So that's the major target that we are having. So our vision and strategy for the Amrit Kal getting over, like, so because government asked all these 100 days and then 2030. Viksit Bharat, this one. So I thought I'll put it in that way. For the next 100 days, we are looking at something called sustainable AI, where we have already have discussions for Indo-German collaboration, where we talk about extreme weather events, then climate models for agri practices and urban mobility. These are the three areas where we are already into discussions, and also we are into discussion with for US Center for Renewable Energy Forecasting, where we will be participating from not only from AI/ML perspective, but also we have a very strong physics-based modeling group. So we will be working together for that. And by 2030, our aim is to see as a one-stop destination for the whole CSIR's data science and AI/ML requirement, but not in as a black box. We want to look at it in a sense of AI for science, where we can explain them. We can use physics. We use the physics in the models. Then especially we do a responsible kind of activity. And our other aim is to create proper capacity and capability across CSIR. Not only here, but here we will certainly create. But I think this is something which has to be.
You have a mechanism to coordinate across
yes.
all its labs for AI.
Yes, that's the CLAIM project that we started with. CLAIM is this is a mission mode project where we have a mechanism to collaborate with all those labs, and we are the coordinating.
Share whatever is developed.
Yes. So one of the development is that actually a collaborative platform is, and which will be connected to our cloud storage. So data will be available, data will be shared, and the codes will be shared. So we have that as one of the output of the CLAIM project. And as 2047, we want to be the leading data science institute in the country, maybe with some global credentials and other things, where government can look at. Yeah, because it was also.
2047 is far away.
Yes. But that's how government wants us to project.
No, much earlier.
Yeah. Yeah, we can do that. Early. Yes.
Because 2047 is this domain is going to
Change.
so drastically. So no point in working 25 years.
So that.
Factor of safety is high.
Okay.
So thank you. That's all for the AI/ML. So if any question is there.
Yes, good. I think I understood a little bit of how many people in this institute now.
So if you look at domain agnostic, right now 2 people are working, me and Dr. Asa. But to be frank, now most of the scientists are working in AI/ML and 4PI. That's one of the achievement that we have done. Most of the
You helped them to all understand.
Yes. So over a period of time, just after when we became a Fourth Paradigm Institute, the first job was to start looking at people and ensure that everybody now understands AI. Yes.
Like another language.
Yes. So, no, that we have. and we are, and our plans, we are recruiting almost, I think, 8, 10, no, 8 plus. Correct. Correct. So we will have a good strength, and most of them will be in AI/ML. So that's what. Yeah. In fact, if all projects comes, then we cannot even handle them right now. So we are.
Of course, students have to you have to prepare quite a bit. But you need to have keeping the knowledge intact. Here.
Yes.
For that you need some internal.
No. That's what we are planning.
Yes, otherwise
should join by May.
Yeah. In fact, they were almost joining, and we just missed in a miss.
Okay, good.
Okay, thank you.
Now I request our headman to please, along with dignitary, onto the dais, please. So would you like to give further remarks on the PPTs that has been presented?
So I would like to request you to ask questions to me.
Yes.
If you have, otherwise we will get into some other discussion. What do you think that person from ISRO will be useful to you? In what way? That is one question, of course. Or anything else that you would like to ask. Only starting trouble, huh?
CSIR always people have starting trouble.
No, everywhere it is, not why you are talking about.
Because I know CSIR only.
You know.
Close contact.
Okay.
We'll take some time here. There was one hand.
Yes, please.
Myself Gaurav, I'm working under Dr. Batra. I'm looking forward for an answer from you. As nowadays AI is going rapidly fast, and we have like domain knowledge, agnostic knowledge, but as far as we are going rapidly fast, there might be some challenges in incorporating it with our work. So what are your views to use those AI that it will how it will help us in research field as far as you concern?
No, see, I think what you asked is a very general question, and I do not have much answers to it. But I can only talk about the specifics that we need to work on in AI. For example, the domain that you mentioned about agriculture, very important for the country. Okay, so and similarly that AI for medical and healthcare, very very important. I think if you can concentrate on that, it will make a revolution in this country. For example, if you go to villages, diagnosis of disease, it's a major problem. For example, you look at now there are a lot of test kits are coming. Okay, and if you can generate huge amount of test kits and make use of this data collection, and then use it for through a type of an AI platform to understand the disease spread pattern, the health database of this country, the type of medical care that is needed to be deployed. It's very very important. Another domain is education. I think education, the way in education, we are all driven by the people who are putting all those tools in front of us. Why we are not coming out with what is needed for this nation? For example, the language, which is very very important. How to bring the beauty of our regional languages to the community. It requires a lot of development actually. The new generation don't even understand the literature of their mother tongue. The beauty of that is missing because the type of education that you are receiving, it actually make you to lose all of that. The art and culture understanding. The nation has a lot of problems of this nature. So if you can look at some of those aspects and how you can bring in AI to help the this is another area. And of course there are many many other things. For example, look at demographics. It's another major area which we are not studied, because the genomics in this nation and how it affects the, of course there are some effort done to put only mapping of only 10,000 people of this country. If you look at that it requires a huge amount of work, but added to AI, it will really help you to understand the pattern of the evolution and other health problem, longevity, the healthcare investment which are required. It's all linked, connected. Once you have a huge amount of database on genomics of this nation, it really helps you. Then of course biodiversity is another major area where the loss of systems, loss of flora and fauna on this nation, and how to preserve this is another area. Like that, there are plenty of focused area that you can work. Security, of course, there are a lot of things that you can do. And technical work, of course, I am not going to say what is going to happen. But what is important for the nation only I am speaking. I think those areas, if you can work, it will be really good. And understand those core area and create a very important effect. For example, India is going to be a digitally empowered nation. I think this has tools like this has huge impact, especially for healthcare and education.
In fact, we have two PhD students who are working in the healthcare sector now.
No, but Gaurav attended that Manipal hospital meeting, no? Yeah. So there we had a discussion on that genomic thing for spinal.
Yeah, it is a huge area. Yeah.
It's a huge area. There's so much untapped potential in that, especially specific to our country.
Yeah. But it's going to change. What you know today is not what you are going to know next 2 years later. I don't know how it's going to change. So that's going to be too fast. That's why 2047 is actually worrying for me.
I think
the whole narrative of AI itself will change in just next 5 years. It's not the one which you know today is going to be the AI tomorrow.
That's why I put it as generic data.
Yeah.
So
it will be very different.
See, I always say one thing, the pace at which it is going now, it's not sustainable, because the way the AI is going, data science, the infrastructure is not able to match that pace. So there has to be
No,
something
it will
disruptive.
see always.
Somewhere
We have a
something
nature of
disruptive.
over predicting. So we have done a lot of over prediction has happened in the science and technology domain. It will replace AI, will replace all work. Everything will be done. Lawyers will become workless. Doctors will have no job. No, all this was predicted. Nothing happened. Okay, even robotics and automation will replace everything. Nothing happened. It all continues. So there is a natural tendency to over predict, but it will all work in reasonably high speed and it will have an impact in society. There is no doubt about it. But it's not going to create a large amount of disruption. I don't think so. So it will grow at a pace which is comfortable with all those limitations. No, if it wants to grow fast, it will not grow. In fact, there is enough of books on AI written. I have been reading one recently.
But somehow I feel by 2030 it's going to be really disruptive.
No,
That's
I
why
don't think
my-
so. There
I
are
don't
both
know,
sides.
maybe,
Both sides
yeah.
arguments. It will disrupt everything. It will not do it because, like computers, they said computers will take over the world. It was predicted in 20s by 2000. It is all computers will take over the whole world, and nothing happens. And we don't even see in another 100 years it is really going to happen. Huh? So
AI is also going to generate new jobs.
no, job is one part. There are other disruptive behavior.
But
no,
that I
which
feel by
is
2030, I don't
the
know.
way in which you
somehow
people
I-
live will change. No, that is what is. It's not. None of that is going to happen. It's only going to progress towards some betterment of the society. That way only we should look at it. But it will have equally a damaging effect also in somebody's hands. Okay. Other anything else? Yes.
I have two questions.
Yeah.
One is there anything specific to greenhouse gas monitoring being done at ISRO?
Yes. Yes.
Monitoring the
Methane.
methane and is there any specific satellite that is?
Yeah, we have developed a methane sensor. Now we have going to launch it in the next mission. We have identified the rock satellite. It's called G20 satellite. G20, you are aware of G20. So G20 nations, we have offered one satellite to be built. Methane sensor is, we have launched one. We have launched and tested. It is working very well. Airborne measurements also done. So it gives you very clear indications of methane emissions across the country. Some papers are also come out from ISRO, which is going to be little troublesome. Okay, looking at that, how much is the methane contribution of greenhouse gas emission. So it is already there. If you are interested, we can get to know more.
Second question is there any plan to deal with the waste debris, space debris?
Yeah, there are. Just now before I started here, I was attending a meeting on that meeting. See, space debris are handled in various ways. One, you cannot do anything with the debris up there. There is no way to remove them. No technology available. No technology is available to them. There are people talking. There are a lot of technologies. Nothing is going to work. Only thing that you can do is to not to create more debris. So we can only bring in guidelines and approaches to bring in no more debris are created. One is after every activity, satellites are to be deorbited. Don't allow them to remain there. So this is one of them. So all satellites in the future should have ability to come back to Earth once its life is over. So this is one. Second is that you should not cause any explosion or collision on board. So this is to be avoided. For that you need observations, you need to have control, you need to have all that coordination between so many agencies so all of them coordinate. So we have created a mechanism by which they all coordinate to handle such exigencies. Then is the rogue nation behavior of creating debris by so that has to be prevented, and everybody should catalog and then inform on a global platform what are you are putting up there, and so that everybody can know and watch and then control it. Then we have to have networks across the country, across the globe on observation. We should be able to see and track and find out what are the debris and observe it. But somebody thinks that you can go there and bring it back. I think they are in fool's paradise,
That
because
is
they are
not-
having tremendous energy and none of them can be brought back. It's not easy at all.
So
Because
whenever I hear
for every debris requires every one rocket.
yeah,
Yeah.
I know, it's
Every
just
piece of debris requires one rocket. Now somebody thinks that I can take a net up there and catch like a fish and bring back. It's impossible, because each one is moving at 5 times the speed of bullet. You will never be able to catch anything.
I know.
Yeah.
So whenever I read, the Starlink, they launch in thousands, Elon Musk, and the Chinese I only worry about space debris. Because
Yes, space debris is already a big problem because the observations
whenever I
telescopic.
read that article, it's like
But now slowly regulations are coming. There are
Coming,
global
yes,
meetings taking
agencies,
place. We are going to host one meeting called Interagency Debris Coordination Committee. It is going to happen on 15th onwards here in Bangalore. All global players are coming here. So ISRO is hosting that meeting. Okay.
We hear this students projects designing these satellites, and then that is being
Yeah.
sent. They're like checked by ISRO before they are.
No, there are different models. Earlier, we used to help colleges to build satellites and launch, called student satellite. We don't do it now because many of the colleges are only for namesake. They do. They put some 2-3 students and faculty do it, and they hire some external people who are experts to build it. And only name of the college comes. So it brings no benefit. So we are not doing that now. So now we are helping only startups or such companies to build it. The college satellite names, such named satellites are not being encouraged, because whatever you do, it must finally bring some result, either scientific result or it create people who will be able to understand it. Both are required, because colleges students work only for 1 year, 2 year. It's not enough to understand the whole thing.
I have one question.
Yeah.
Do you think private players in space, it is a double-edged sword? Is it advantageous?
So it's so much advantages. I think without understanding this, see, we have a problem with the government job. We find more secure, and we would like to do it everything by ourselves. But you understand, private is actually contributing much higher to the
DDP.
for the economy of this nation. See what exactly the public sector has done. Public sector had a role to play in the beginning of the nation building. Once a certain maturity has come, then it has to be handed over to private players. It's very, very important. But private players always work for profit.
Profit, that is.
It is natural. So that means something that was reached a threshold of profitability can only be transferred to private. Until then, it has to be handled by public expenditure. For example, railways. Once you have developed the railways to a certain extent, and now railways can be run profitably by a private operator, then it is the right time to hand it over to private operator, because there is no role to be played by government to keep it active. Look at airline. It is also like that. Airline infrastructure, once it has reached a threshold of profitability, it has to be handed over. So similarly, space also, there was no space 60 years back. We created it with the public money, and it has reached a threshold now. Now the space can be operated on profitable basis, like you can launch satellites, you can deploy communication systems, you can remote sensing applications. So there is money in that. And when money is visible, private can come. But then it is not for money alone, private. Once the money is there, they know how to invest and innovate to create more money. That is better known in private than in public. Because so we'll have to create only such companies, such institutions to allow innovation and competitiveness among global players. Now the world is working in a global level, and if you are able to compete with a global player, only you are going to survive. So you look at the car business. How you just look at the car business. If it has been limited only, if you are not allowed foreign direct investment for car manufacturing in India, we will all be driving only the same car, Ambassador. Nothing would have happened. Today we are able to do new cars, and now companies are coming up with an ability to design here. So it's important to create that capability in industries, but it is a very careful. It has to be done in a very careful manner. Not everything should not be opened. You should open only to allow short gestation period, profitability. For example, look at huge private players are there. Geo is there. Geo has not invested in creating R&D. See, now what we want is private companies to create research laboratories. Okay, so now research labs are always funded by government. Why not a private company create research lab? You look at America, most of the universities are actually private. There is no government university. We have a collaboration with the Jet Propulsion Lab and Caltech. Both are private. JPL is a private institution which is designing most of the space missions of America. Okay. And Caltech is a private university. So Caltech funding is from private government to run as a private university, and they do all the research work for space activities. How they are able to do? Why an university in India is not able to do that? So we have to encourage private investment in research And even universities in private should invest in research. But all of them look at only profit for time being. But after some time, you will understand, unless you invest in research, private companies also cannot make profit. Because the innovation is the one which gives you profit. For example, look at mobile phones. If you are simply a manufacturing base in India is developed, nothing is going to happen. Only they will dump the manufacturing. But over some time, you will see some of the Indian companies will start developing new mobile phones, new techniques, new approaches, new manufacturing methods. Slowly it will come. It will take years, but it will happen. Slow. Encourage private in a controlled manner. It will
Even
it will help.
NASA is doing that. No?
NASA is fully private.
Fully private now.
Yeah, it is all private, and they only their job is to encourage private, and even human spaceflight is now private.
That one also.
Yeah, because Axiom Space is a company who is actually doing human spaceflight in America. So even our astronaut is going to fly through a private contract in International Space Station, not through NASA. So
Oh.
things are changing. It was earlier NASA. Now NASA is
now
only a
the
coordinator, not
coordinator.
a engineering agency.
I have a couple of colleagues there who I
Yeah.
keep in touch. So
But everybody say NASA, but the NASA contractor they will be.
yeah,
People say I work for NASA, but they
NASA,
are
but
actually
they
working in a private
contracted for
company
NASA.
working for NASA. Yeah. NASA per se are very less people.
very few people. I know two of them original NASA people, which we have become over the years good friends. So they keep updating.
A lot of Indians are there. Even in JPL I go, I find almost hundreds. This many people I went to JPL. But so many researchers from India. Yes. And in fact, I had to leave some place.
You know, oh, but you are not going to visit a facility.
Yeah, we'll visit and go. Thank you. So excellent thing. I really happy with the presentation. We'll keep connected. Okay.
Vote of thanks, sir.
Okay.
I request Dr. Imtiaz Ahmad Parvez, sir, to please propose vote of thanks.
Photo also they want that.
Normally, what is your working time here? Huh?
8:30 to 5.
So good afternoon. Yeah, we are really at the end of this wonderful meeting. So, Honorable our society member, Shri Somanath ji, Secretary, Department of Space, Chairman ISRO, and our head, Dr. Shri Devi, my fellow colleagues. So, on behalf of our institute, I extend our heartfelt gratitude to Shri Somanath ji for gracing us with his presence today. His insightful discourse has enlightened us all and left an indelible mark on our minds. Shri Somanath ji, your illustrious career in ISRO and your pioneering contributions to the advancement of space technology is an inspiration for all of us. Your visionary leadership has propelled India's space program to unprecedented heights, making us a global leader in space exploration. And today, your address and your remarks has not only provided us with valuable insights but also motivated us to strive for excellence in our respective fields. We are deeply grateful for the time you have taken out from your busy schedule to be with us today. Your presence has added immense value to our event, and we are honored to have had the opportunity of learning from your expertise. As a token of honor and pride, I request our head, Dr. Shri Devi Jade, to present a memento to Shri Somanath ji.
Small memento.
So, once again, thank you, sir,
On your energy level.
for your enlightening words and your gracious presence. Sir, we are indeed very much honored to have you as a mentor. We look forward to continuing our association with you and benefiting from your wisdom in the future. And I also like to thank our head, Dr. Shri Devi Jade, for her valuable inputs and encouragements to all of us. My special thank to all my colleagues, Rajendran, Anil, and Gopal, who have given very nice, brief, and crisp presentation. And I hope our mentor had liked it, and then he will continue to support and give the inputs to all colleagues in 4PI. And I thank all my colleagues, support staff, students, FMS team, and all contact staffs, all our students to be the part of this event. I also thank Office of the Head, particularly Mrs. Radharamani, who has been coordinating this event very closely. Once again, thank you one and all. Jai Hind. Now we will stand for the national anthem.
That we always do. Part of Thank you.
So some actions can we suggest that I will request some of my colleagues to come here, because I have not given any presentations on what we are doing. So I propose maybe when you are convenient to you to assemble like this, I will tell some of my colleagues to come and speak about what we do on some of the related domains, so that we can identify what can be done. Because now I understood who should come.
Yeah, okay.
Okay.